Shall we start?
1 minute, sir. 1 minute.
Okay. Okay. So first, let me draw the Brayton cycle. So 1 to 2 is adiabatic compression, 2 to 3 is isobaric heat addition, 3 to 4 is expansion in the turbine, and 4 to 1 is heat rejection isobarically. PV, TS, same thing. 1 to 2 is isentropic compression. No? Adiabatic is also called as isentropic. So 1 to 2 there, 2 to 3, 3 to 4. So this is the Brayton cycle as of now just given. Now, let us go with the problem. Air enters the compressor of a gas turbine plant operating on a Brayton cycle at 101,325 kPa and 27 degrees Celsius. So what is this parameters given? Air enters the compressor, he says. So what should I take it as?
P1 and P2.
Yes, so I will write it as
P1
P1 there. So P1 is equals to 101.325 kPa. Similarly, the value of T1 is 27 degrees Celsius, so it is 300 Kelvin. I'm writing it directly. The pressure ratio of the cycle is, so pressure ratio in the sense it is beta, it is P2 by P1, or I can write it as P3 by P4, which is equals to how much? 6. Okay. Now, P1 is also equal to P4. I'm just writing it here. P1 is also equal to P4. Calculate the maximum temperature in the cycle and the cycle efficiency, he says. What should we calculate?
T4.
To find
T2 and T3.
maximum temperature. So which one is maximum?
T3,
Whether
T3.
Okay. So T3 is maximum. So maximum temperature T3 you have to find out. Next, cycle efficiency. Efficiency of the Brayton cycle you have to find out. Okay. So hints what he has given us. The turbine work is equal to 2.5 times of the compressor work. He has given it as turbine work is 2.5 times of the compressor work, where W2 and WT are the turbine and compressor work respectively, and even he has said us to take the value of gamma as 1.4. Well and good. Let us start with the solution. Okay, so how to proceed with the problem? Can I find out T3? First question is, you have to find out the value of T3. So how do I find the value of T3?
Pvt
conversion.
Okay, Pvt conversion equation I will use. Pvt conversion equation. So 3 in the sense I have to use it for 3 to 4, which is adiabatic expansion. Okay. For this, if you apply the Pvt conversion equation, it says it is P3 by P4, that is equal to V4 by V3 whole to the power of gamma, that is equal to T3 by T4 whole to the power of gamma divided by gamma minus 1. Now, in this case, P3 by P4 in the sense it is nothing but the value of beta,
6.
which is equal to 6. Now that is equal to here. Do I know the value of T4?
No.
Do I know the value of T4?
No, sir.
Then how do I find out it? Two unknowns cannot be found. Yes. Agreed with my statement? Can you find with Pvt conversion equation there? Can you?
No, sir.
Then how do I find out this? What's the next option? So just keep in terms of T3 by T4 as it is. Let us see T3 by T4 is equal to 6 to the power of 1.4 minus 1 divided by 1.4. From this, T3 by T4 is equals to how much?
One 1.66.
1.66. That's it. What is the next digit?
85.
Excuse me, sir.
Yes.
So how we have reciprocal that power, sir? Like 1.4 minus 1? So I didn't get that one.
No problem. A to the power of m by n is equals to b. Okay. If I transfer the power to the either side,
Yeah, n by m. Yeah, got it, sir. Yeah.
A is equals to b to the power of n by m. Hope you got that.
Yeah, got it, sir.
T3 by T4 bantu. Ishtena idu. I want some more digits to be precise.
85. 85.
Okay, 8 are concept. I will take it as 8. So from this, T3 is equals to 1.668 T4. ಇಲ್ಲಿಗೆ ಬಂದು ನಿಂತಿದೆ ಗಾಡಿ. ಮುಂದೆ ಎಂತ ಮಾಡೋದು? What can be done next? What can be done next? Any hints given in the problem? Just look at that. Any hints which is given so that I can use it? Any hints which is given in the problem? How to solve this further? Any hints given in the problem? T4 T4 ಕೊಟ್ಟಿದ್ದಾರಾ ಪ್ರಾಬ್ಲಮ್ ಅಲ್ಲಿ? T4 ಕೊಟ್ಟಿದ್ರೆ ನಮಗೆ ಪ್ರಾಬ್ಲಮ್ ಇಲ್ಲ, ಡೈರೆಕ್ಟ್ ಆಗಿ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿದ್ರೆ ಬಂದ್ಬಿಡುತ್ತೆ. ಬಟ್ T4 ಕೊಟ್ಟಿಲ್ಲ, ಅದೇ ಬರುತ್ತೆ ಪ್ರಾಬ್ಲಮ್ ಈಗ.
Put T3 is equal to 1.668 into that Pvt equation, sir.
Once again, Anish.
So put T3 is equal to 1.668 of T4 in the Pvt equation, sir.
In which equation I'm supposed to substitute T3 as 1.668 T4?
6 is equal to beta is equal to T3 by T4.
See, one thing. Mathematically, let us try to analyze this, Anish, okay? What happens, I have derived this from this particular equation itself. Okay, if I try to substitute the same thing in the above equation, I would just get LHS is equal to RHS. Am I right?
Yes.
So what we have to do? So look, if you're stuck in between. So for example, in this particular problem, ನಮಗೆ ಏನು ಮಾಡಬೇಕು ಗೊತ್ತಾಗ್ತಾ ಇಲ್ಲ, ಎಲ್ಲಿ ಎಂತ ಮಾಡೋದು, ಏನು ಮಾಡೋದು.
Sir, we can derive.
What we can derive?
Their equation is work done for turbine equals to 2.5 of work done of. In that we can substitute.
Yes, very good. So in such cases, what you have to do? Some hints will be given in the problem. For example, this: the work done of the turbine is 2.5 times the work done of a compressor. Take that. Let us see. Let us try to analyze. If you get it, it's fine. Let us see. Okay. Now, what he has given? What is the statement given there? Work done by the turbine is equals to how much? 2.5 times of work done by the compressor. Correct? Am I right?
Yes, sir.
Yes.
Now, what is the formula to calculate work done by the turbine? So work done by the turbine. Go ahead. M
CP.
Yes.
T3 minus T4.
T3 minus of
T4.
T4. That is equals to 2.5 times of MCP into
T1 minus
work done by the compressor. T1 minus of T2. Am I right? Correct?
Yes.
Now what happens? MCP will go away. Correct? Right? Next, whatever is remaining, I will be writing down here. T3 minus of T4, this is equal to 2.5 times of T1 minus of T2. So, in this particular sort of equation, what to do now? T3 I can substitute it as how much? 1.668 times of T4 minus of T4 is equals to 2.5 times of T1. T1 is how much? T1 is given, I guess, 300 Kelvin. Okay, minus of T2. What to do next? Again, there are two unknowns.
T2 you should find by Pvt equation.
Very good. So see, one thing is there, just to try to analyze this. This particular equation is being given for you, thinking that both turbine work and compressor works are positive. Okay, this particular equation is being given, it is 2.5 times of compressor work, thinking that these two terms are positive. Okay, so if I substitute the value of T1 minus T2, what will be my work done?
Negative, sir.
Negative, isn't it? Then this particular equation will not match. In order to match this particular equation, what should I do is, I should just change the sign from T1 minus T2 to T2 minus T1 just to match the equation. Okay. So it is T2 minus 300. Now, if I get the value of T2 somehow, I will be in a position to calculate the value of T4. Thereby, I can calculate the value of T3. Now, how do I calculate the value of T2? How do I calculate the value of T2?
Pvt conversion.
Pvt conversion equation. For which process I should apply?
1 to 2.
Which is adiabatic compression. Very good. So for adiabatic conversion, 1 to 2 is P1 by P2 is equal to V2 by V1 whole to the power of gamma, that is equal to T1 by T2 whole to the power of gamma divided by gamma minus 1. P2 by P1 is beta, so P1 by P2 is 1 divided by beta. So it is 1 divided by beta 6. That is equal to, now I will be taking this particular equation here. It is 300 divided by T2 whole to the power of 1.4 divided by 1.4 minus 1. So from this, what is the value of T2?
Sir,
Hmm?
can you solve this, sir?
ಏನಪ್ಪ
ಅದು
ಏನಾಯ್ತು?
ಕ್ಯಾಲ್ಸಿಯಲ್ಲಿ ಚೂರು ಕನ್ಫ್ಯೂಸ್ ಆಗ್ತದೆ ಸರ್.
Easy ಕಣ. Okay, ಕ್ಯಾಲ್ಸಿಯಲ್ಲಿ ಕನ್ಫ್ಯೂಸ್ ಆಗ್ತದೆ. I will solve this for you. Okay, it is 1 by 6 is equal to 300 divided by T2 whole to the power of 1.4 divided by 1.4 minus 1. Transfer the powers to the either side. It would be reciprocal of it. It is 1 by 6 whole to the power of 1.4 minus 1 divided by 1.4. That is equal to 300 divided by T2. Now, from this cross multiply, T2 is equals to 300 divided by 1 by 6 whole to the power of 1.4 minus 1 divided by 1.4. Now, what is the value of T2?
500.
ಯಾರು ಕೇಳಿದ್ರಲ್ಲ ಕನ್ಫ್ಯೂಸ್ ಆಗ್ತದೆ ಅಂತ, ಕ್ಲಿಯರ್ ಆಯ್ತಾ?
ಗೊತ್ತಾಯ್ತು ಸರ್, ಗೊತ್ತಾಯ್ತು.
Okay, so it is 500.23 53 Kelvin. Matching the sign conventions on both the sides. Both the sides we have. ಆಯ್ತಾ? ಇದು T2 ಬಂದ ತಕ್ಷಣ what is your next step? Use this particular equation to calculate the value of T4. Copy. So in this equation, so T2 value is how much? It is 500.53. So what is the value of T4 in Kelvin? Next, finally, T3 is equals to, 1.668. 1.668 times of T4. So it is 1.668 times of whatever value you get. So final value of T3. $300 ಯಾವುದು ಆದಿತ್ಯ? T4 ಆ?
T4, sir.
Okay, so 300.589. So substitute here 300.589. So give me the value of finally the maximum temperature. Just check the values remaining. Make sure the values are right, because if one value goes wrong, all the problem will go wrong. ಎಷ್ಟೊತ್ತು ಬೇಕು T3 ಕೊಡ್ಲಿಕ್ಕೆ?
Sir, 501.382.
ಏನ್ T3 ಯಾ?
Yes, sir.
Yes, sir.
ಅಷ್ಟೇನಾ? Only this much is the value, maximum temperature. Hello, T2 value it is 500. Correct?
Yes, sir.
Just check the value. Somewhere you might be have gone wrong. Just check the T4 value. I'm getting doubt about this.
750 I'm getting, sir. T4.
750.48, sir.
Node. There is a mistake.
T3 1251.
ಒಂದೇ ನಿಮಿಷ. ಈಗ ಹೇಳಿ ವ್ಯಾಲ್ಯೂ T4 ಎಷ್ಟಿದೆ? 750 Kelvin. If I substitute 750 here, what is the value here?
1251.
1251. ಆದಿತ್ಯ ಚೆಕ್ ಮಾಡು ಎಲ್ಲಿ ರಾಂಗ್ ಆಗಿದೆ? ಆದಿತ್ಯ?
Yes, sir.
ಏನ್ ರಾಂಗ್ ಆಗಿದೆ ನೋಡ್ಕೊಂಡ್ಯಾ? ನೋಡ್ಕೋ ಎಲ್ಲಿ ರಾಂಗ್ ಆಗಿದೆ ಅಂತ. ಕ್ಯಾಲ್ಕುಲೇಷನ್ ಏನಾದ್ರು ಮಿಸ್ಟೇಕ್ ಮಾಡಿರ್ಬೋದು. How many of you are getting the same value? T4 value wrong ಆಗಿದೆನಾ?
ಅದು whole divided by.
Okay, ತೊಂದ್ರೆ ಇಲ್ಲ. So if you are getting the same value, for me T3 is the important final answer. So if you are getting 1251, just raise your hands, let me see. Anish is also getting that. Okay, as you Sujan. Okay, Ritesh. Okay, fine. So this is the value of T3. Okay. Next, what do you have to find? Second bit, what do you have to find? The efficiency of the Brayton cycle. See, this efficiency of Brayton cycle can be found in two different ways. Okay, number one, it is given by output by input, so work net divided by heat supply. Okay, work net is again WT plus WC divided by QS. How will you calculate WT? It is MCP into, come on, WT. Hey, WT.
T3 minus 2, sir.
T3 minus T4 plus MCP into WC is 1 to 2 for
T1
work net is
minus
initial
T.
final. T1 minus of T2. QS is from 2 to 3. For heat, it is final minus initial.
T3 minus T.
T3 minus T2. So all the MCPs will get cancelled, right? So whatever is remaining is T3 minus of T4 plus T1 minus of T2 divided by T3 minus of T2. Substitute all the values. Substitute all the values and give me the value. T3 is today 1251 minus T4 is 750. This is done. Plus T1 is 300. 300 minus T2 is 500 divided by T3 is 1251 minus T2. T2 is 500. So if you multiply the whole thing into 100, you will get the value of the efficiency of Brayton cycle in percentage.
Forty point 03.
40.03 is the efficiency. Okay, now we can even have a check. So I told you this is one of the method, or you can follow efficiency of Brayton cycle is given by what it is given as 1 minus 1 divided by beta whole to the power of gamma minus 1 by gamma. Right? So just substitute, you know the value of beta. What is the value of beta, by the way? 6 ansatala. Correct? So 6 whole to the power of 1.4 minus 1 divided by 1.4. If you multiply this whole scenario into 100, you will get efficiency of Brayton cycle in terms of percentage. So just check whether it is same value or not. So if you get the same value, then a high five for you.
40.06, sir.
40.06. In and around, it is the same value. Okay. If you get the same value, just raise your hands. Okay. So how are you feeling about the problems on the Brayton cycle? Only two things you have to remember. How to calculate work. For it is initial minus final. For heat, it is final minus initial. MCP delta T. This is the formula. 1 minus 1 divided by beta whole to the power of gamma minus 1 by gamma. All Pvt conversion equations. Okay. So if you remember this, the problem should be easy. So how are you feeling the problems on Brayton cycle? Easy? Okay. No one has answered me, man. How are you feeling the problems on Brayton cycle?
Same, sir.
Easy, sir.
Okay. So ಎಲ್ರಿಗೂ ಆನ್ಲೈನ್ ಕ್ಲಾಸ್ ಕೇಳಿ 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 ಸಾಕಾಗಿರುತ್ತೆ.
Yes, sir.
ಹೌದಾ? So